1.031 बार पर हमारी 331.37 kg/h है। अमोनिया की जो डेंसिटी है वो हमारी 1.013 बार पर हमारी 682 kg/m³ है। अमोनिया लिक्विड की स्पेसिफिक हीट जो है वो हमारी 6.91 kg/kg केल्विन है। तो हम लोगों ने इसको मतलब कुछ ग्राफिक्स भी डाले हैं इसमें, जिसका इस तरह से हम लोग यहाँ प्लांट में हम इसको यूज कर रहे हैं। तो इसमें वेपर कंप्रेशन साइकिल का भी हम लोगों ने ग्राफिक्स डाला है इसमें। कुछ कुछ पैरामीटर्स भी हम लोग मॉनिटरिंग करते हैं, जिससे कि हमारी इसमें रनिंग कॉस्ट कम रहे और हमारी सीओपी ज़्यादा रहे। उसके लिए हम इसके सक्शन प्रेशर और टेम्परेचर को हम सक्शन प्रेशर और डिस्चार्ज प्रेशर दोनों को हम मेंटेन करते हैं। एक ऑप्टिमम मेंटेन करते हैं। अगर हम ज़्यादा लो सक्शन प्रेशर भी हम यदि रखते हैं तो भी हमें मतलब कॉस्ट ज़्यादा रहेगी। और आजकल जो नई जो है टेक्निक जो है, हम जो रेफ्रिजरेंट के इसके सब कूलिंग और सुपर सुपर हीटिंग टेम्परेचर हम लोग मेंटेन करते हैं, तो हमसे इसमें सीओपी हमारी इंक्रीज हो जाती है। तो इसके पंप के जो सक्शन जो कंप्रेसर जो है हम उसके सक्शन में हम लोग है इसका टेम्परेचर है मतलब थोड़ा सा जितना ज़्यादा आ जाता है एवोपरेटर के बाद में, उतनी ही हमारा इसमें हमारी सीओपी बढ़ जाती है। और हमारे कंडेंसर के बाद में अगर हम इसको जो लिक्विड फेस में हमारा जो रेफ्रिजरेंट आया उसमें अगर हम सब कूलिंग कर लेते हैं तब भी हमारी मतलब सीओपी बढ़ जाती है। इन दोनों चीज़ों पे अभी वर्तमान समय में हम लोग ज़्यादा ध्यान दे रहे हैं। थैंक्स फॉर।
दादाजी एक चीज बताइए, ये जब 88 में प्लांट लगा था, उसके बाद जब अपग्रेडेशन हुआ था तो इसमें भी कुछ चेंज हुआ था क्या?
अब इसके बाद में जो नए प्लांट आए हैं उनमें हम लोग जो कंडेंसर के बाद में हमारा जो टेम्परेचर मिलता था 30 डिग्री टेम्परेचर आता था हमारा, उसमें हमने इसमें सब कूलिंग करके हम इसको टेम्परेचर को 12 डिग्री टेम्परेचर तक ला दिया गया। इसके बाद में हमारी जो मतलब है रेफ्रिजरेशन है पर जो लो टेम्परेचर में जब हमें एवोपरेटर में ले जाते हैं तो वहां पे हमें मतलब है इसमें सर्कुलेशन जो फ्लो है एवोपरेटर रेफ्रिजरेंट का वो कम हो गया हमारा। उससे हमारी काफी एनर्जी सेव हुई है।
इफिशियंसी बढ़ गई होगी।
सीओपी बोलेंगे अपन इसमें, रेफ्रिजरेंट में सीओपी बोलेंगे हम लोग, एक ही बात है। हाँ।
ओके। और किसी को कोई प्रश्न पूछना हो तो मालवी जी। खेतान साहब, कुछ पूछना हो तो ठीक है।
यस सर, यस सर। मेरा जो है द फर्स्ट क्वेश्चन टू बलवीर जी इज that what is the purpose of and what is the utility of refrigeration in and fertilizer industry? इसका उपयोग क्या है सर?
न- ये सबसे पहले तो हम लोगों को हीट ट्रांसफर को समझना पड़ेगा। हम लोग एटमॉस्फेयर से एवोव में तो हम किसी भी तरह से हम टेम्परेचर डाउन कर सकते हैं, जो एटमॉस्फेरिक टेम्परेचर चल रहा है। तो किसी भी मतलब हम दूसरे लिक्विड से हम लोग इजीली हम लोग हीट ट्रांसफर कर लेते हैं। लेकिन जब हमें एटमॉस्फेयर से बिलो अगर टेम्परेचर है तब हमें रेफ्रिजरेशन की इफेक्ट पड़ती है। जिस तरह हम लोग पुराने जमाने में आइसक्रीम बनाने के लिए हम लोग पहले जब हमारा आइस नहीं होती थी उस समय हम उसमें वाटर में नमक डालकर हम उसका टेम्परेचर -32 तक आ जाता है, जिसे हम लोगों ने जो फ़ारेनहाइट जो स्केल में 0 डिग्री सेंटीग्रेड हमने टेम्परेचर टेम्परेचर माना है वो यही पॉइंट है हमारा, कि -32 तक हम पानी में मिला के हम ले जा सकते हैं। तो ये कुछ प्रोसेस है हमें एटमॉस्फेयर से बिलो टेम्परेचर लाके हीट एक्सचेंज करने की, यही एक प्रोसेस है रेफ्रिजरेशन सिस्टम।
ओके सर, ओके।
थैंक यू।
थैंक यू सर।
थैंक यू। अब हमारे नेक्स्ट पैनलिस्ट हैं डॉक्टर प्रोफेसर CS मालवी जी, जो HOD भी हैं MITS ग्वालियर के, और साथ में हमारे इंस्टीट्यूशन ऑफ इंजीनियर्स इंडिया ग्वालियर लोकल सेंटर के चेयरमैन भी हैं। तो मैं मालवी जी से आग्रह करूंगा कि वो अपना वक्तव्य दें। श्री
Thank you.
मालवी जी।
Thank you, Engineer Shukla ji. I'm sharing my presentation over here. I hope it is visible to all.
Yes. Yes, sir.
Thank you, Engineer Balveer Singh ji Lodha ji, who introduced refrigerant and refrigerant system. So I will not repeat whatever he already explained this thing in the system. I will talk most of the things on domestic refrigeration only.
The presentation is not visible to us.
Okay, I'll try it again.
Yes.
Is
Yes,
it okay
now
now?
it has come. Now it has come. Okay.
Visible.
Yeah.
Yes, sir, visible.
Okay. As the title name is Trends and Innovation in Refrigerator. Okay. So I'm not talking much about the innovations because for me, innovation is really very confusing word. And there's an innovation maybe for me, and this might not be useful or noble for you. So I'm just explaining in next 5 minutes what is trends are in the market, particularly in the internet I found over here. If I say this thing, can a refrigerator change the color? Otherwise, all refrigerators simply are box. Upper top side is the cooling section. The bottom side has some vegetables and some cooling and milk and cold drink, etc. Can it change the color? Otherwise, it's boring. What we do, we go for a moment, we take a round on the world tour and put the refrigerator magnet is for memorizing this thing. Otherwise, the no use is a metallic box. Yes, that will be a fantastic idea if a refrigerator can change the color. It at least this can make your wife happy. Okay, it matches this thing. So it's true. Like you can see the HNK parts, home and kitchen appliances provide this thing, this thing. Otherwise, also there are various things are covering which can come over here, which you can change its color. So it's really good idea. It's in trend that refrigerator can change the color. My second question is, can a refrigerator play the music? Otherwise, Alexa is there, Siri is there, you have the home Wi-Fi system, home theater system. But what else if, in either in my home, the speaker are kept up above the refrigerator. Okay, there's a base box. And same thing, I was thinking, what if a refrigerator can play a music? Again, if I found this thing, is that there's a facility? Yes, there's a facility. HKMK also provide this refrigerator with music system. It's a fantastic idea. Otherwise, simply humming sound. Well, after that, I found what are the top refrigerator brands in India. It might be for 25 and 26 last 1 year. Vinay ji, मेरी आवाज आ रही है?
आ रही है सर.
Okay.
Yes, sir.
Yes. Yes. So top refrigerator, if I found this thing, is of course there is a Petcas company, you can call it like LG over there, which is reliability, quiet operation, energy saving. And inverter is everybody is talking about the inverter lining compression, which provides the LG and smart ThinkQ features. This is the style of the LG. They give some feature and they give the different name as well. Then the Samsung excel in inverter technology, twin cooling, smart featuring technology, versatile and convertible refrigerators, and then Whirlpool, Some of these students are working in the Whirlpool company as well. I own Proton company, Proton model of the Whirlpool at the this thing. IntelliFish inverter. I don't have an inverter one. Excellent vegetable for preservation is there. Then Godrej, then a higher. Offer value for the money and strongest. So these are the top. This might be a list different for you, but there is a common list you can find in the market. Okay. I'm discussing only 5 trends on which these trends run, and people appreciate the idea of refrigeration and buy it. First is energy efficiency. Everybody is talking about the energy efficiency, inverter, compressors, and high coefficient of performance. Like Lodha Saab already said this thing, star rated eco design. So whatever star rating from the BEE is given last year, maybe not same for this year. This 3 star may become 2.5 this year, because every time we are expecting more energy efficient for this thing. On this thing, Samsung is really doing well. Number 2, IoT enabled technology. Smart and IoT enabled refrigerator. Your refrigerator may have Bluetooth. Your refrigerator may talk with your mobile phone. Your refrigerator may have sensor and connectivity. It can be operated by remote control. AI based cooling system are coming with. This is called IoT enabled refrigerator, and many companies are offering the same thing. You might have seen for the refrigeration, like one Amitabh Bachchan advertisement, Lloyd, when he was parking in basement his car, he used his mobile phone to put on his air conditioner at his floor. Whenever it will take hardly 15 minutes to reach his whole flat and the outside. So till then, it will cool the room. So you don't need to start it again. So these are AI based or remote monitoring science and technology are coming, and people are really liking this thing. Even there's a simultaneously another side as well. If I missed to switch off the AC, or the light was not there and I missed to switch off the AC, okay, so I can remotely, I'm from my office, I can switch off that AC. So these are again in trend. Of course, Lodha Saab already talked about the refrigerant R600A, R29 and 290, low GPB refrigerant, compliance with the global norms. The new refrigerant are coming over there. Environmental friendly, non-toxic, non-unhealthy. Hydrofluids are there. There's a long series R123, R1234, RE. I think Lodha Saab has already talked about this, so I'm just saying this thing. Eco-friendly refrigerants are coming to the market. Then what they want multi-airflow system, means advanced cooling technology, frost-free cooling. Otherwise, if I think 20 years back, there's a water, you will find condensed water in the bottom, in the room as well. You need to put a button, defrosting button, a frost-free cooling over there. So it's automatic over there. Vacuum insulation panels are there. Air cooling, liquid cooling, immersion cooling, and phase change. There's a variety of the things they are coming with the advanced cooling technology. Now, number 5, in trend, sustainable and modular design. The fantastic design are coming. The recyclable materials are coming. The modular component, you can see, it seems like a Almira, which has a variety of the doors and various segments of the different purposes. Everything is kept over there. I mean, all things is kept in this thing. My wife keep like that coconut powder and maida and suji in that cooling box, because if we keep in open, they say there's a you may find some of the mice over there. There might be some ants over there, to protect from the environment, not the environment, from the insects also. They keep all the powders in this segment. Ease of repair and update. And they, again, if we visit Flipkart, in Amazon, you will find variety of the accessories are also in trend for the refrigerator. If you buy a simple box, what accessories are required for the refrigerator? Like, you will find different type of the storage boxes and bin, refrigerator drawers and mats liner you will find over there. Doors and shelves are there, egg holder and dispensers. There's a variety that you don't need to open a door to take water. There's a tap already there from the outside. Egg holders, magnetic side racks, rotating organizing trays, water filters, including in that fridge, air filters, odor absorbers, refrigerator thermometers, voltage stabilizer, replacement parts, trolley, and find the perfect combination. With these trends, I really appreciate for calling me over here for the presentation. Thank you. Thank you very much, all.
Thank you, sir.
Thank you. I remove my question.
So, thank you, मालवी सर. काफ़ी कुछ चीज़ें जानने को मिल रही हैं, नई भी और पुरानी भी. पुरानी तकनीकी क्या थी, ओल्ड टेक्निक्स एंड नाउ न्यू टेक्निक्स. अब मैं इंट्रोड्यूस कराऊंगा अंशुमन खेतान जी को, जो ईसी में बीटेक हैं और अभी एमटेक कर रहे हैं. तो अंशुमन जी प्लीज़ टेक.
Yes, sir. Thank you. Is my screen visible? Is my presentation visible?
Yes.
It is visible, yes. So you can make it in that full screen mode if
Yes,
possible.
yes.
Yeah.
Yes.
Yeah.
So good morning, everyone. Good evening, everyone. My name is Anshuman Khaitan, and I'm going to present my presentation on the topic of sustainable refrigeration. We discussed technical points about refrigeration from our previous speakers, so I will not go deep into them, but I'll talk us about a certain part of refrigeration or a part of the industry, that is sustainable development of refrigeration systems. Because in today's world, because of growing temperatures, climate crisis, and other things, we have a larger and larger requirements of refrigeration systems. But at the same time, these refrigeration systems, due to multiple reasons, also cause the increase in temperature, or the world general temperature level of the world has increased due to some of these things. So I'll talk about how some sustainable development that can be done in refrigeration systems. So what's our challenges? 15 to 20% of the world's electricity is being used by refrigeration systems. In this case, refrigeration systems refer to both refrigerators in our homes or cold storages in large warehouses, to our ACs, our general cooling systems that we ourselves use to generally live in a country like India itself. Because in India, temperatures are generally quite high in summers, almost always crossing 40 degrees at peak these days. Now, the greenhouse gases emitted by refrigerations also contribute to the overall increasing temperature of the world itself. There's some, because of the gases being used in our refrigeration systems, there is some amount of gas leakage that occurs almost every second or every year, because of multiple reasons. They might be due to technical issues, might be some wear and tear. Just from being used, there is some minor amount of leakage. So this produces some emissions that are harmful for the world itself. There is also the demand of increasing, as I said, the temperatures are rising in the world itself. The overall average temperature of the world has already risen by more than 2 to 3 degrees in the past 10 years itself. So there is an increasing demand for temperature control, for refrigeration for ourselves and for food products or any other reasons. the refrigeration market is estimated to reach $69.4 billion. And if projections that are being made are correct, by the year of 2040, that that market would increase to a level of 200 above 200 billions at a base level, because each year the refrigeration demands are growing for food purposes, for human sustainable purposes, for industrial purposes, or any for any other reasons. One of the biggest refrigeration demands is for servers itself. These AI farms that are being developed these days, that are being set up in across the world, they require a huge amount of refrigeration for their electronic components, for their server grade equipments, because only in extremely cold temperatures can these systems work. Otherwise, because of the temperature they emit and the huge amount of current that passes through them, they produce a huge amount of heat that, if not cooled, would cause a meltdown in all these server farms, and all the delicate computer equipments would no longer work. So for sustainable development in refrigeration, these are the 5 pillars of refrigeration. We can say are 5 pillars of sustainable refrigeration. That is energy efficiency. We need to increase the efficiency of our refrigeration systems. Even if by a small step, we need to work on it daily, year by year, so that we may reduce the energy consumptions that occur due to refrigeration operations. We need to develop on that. We need to use alternative solutions, natural solutions that may be available for us. For natural refrigeration, we can use ammonia. As previously said, ammonia has high efficiency and easy to use in industrial purposes, as was previously discussed. So this was one of the alternatives that we need to develop more upon. There's the circular economy. That is, we need to develop the durability, repairability, and recovery of these refrigeration systems, because in most cases these days, the equipment that are being made for any purposes are mostly have a low durability. That is mostly due to planned obsolescence or other reasons, and they also have very low repairability. It might be due to company itself, might be due to the materials used, but generally these days repairability is low for these systems. There's also the recovery, because we cannot recover a damaged product easily, so it affects the sustainability of these refrigeration systems to be reused and produce a longer, better effect. As I said, we need to use renewable energy in refrigeration systems itself. We can use liquid cooling for underground systems, because we can use geothermal systems for refrigerations in underground sources, or we can use liquid cooling purposes that do not produce as much as harmful effects on the global level. And we need to have some systematic changes, but this is a long-term thing, and we need to work on it year by year. As I said, energy efficiency is one of the major things that we need to look into. So for operation purposes, we need to make sure that, let's say we use a refrigerator at home that is almost always only filled 50%, yet we still use it at full force, so that so it works, it chills at the same level even if we reduce the temperature a bit, but it still produces, it still uses that amount of energy as if it was 100% filled. So we need to develop IoT solutions. We need to develop machine learning solutions for these purposes, that if we have, say, a 50% filled warehouse, or instead of 100%, or a 75% filled warehouse, or even if it's just 25%, the endeavor of technology should be so key that the system itself would understand that right now the demand for refrigeration is lower than the average that is required, and so we can do additional saving for from both electricity and for any gases that are being used, because if we lower the temperature, or if it has higher efficiency, the emissions would be lower as well from these refrigeration devices. So here's are some natural refrigerants that are being used. So this is a minor chart that is showing that how we need to reduce the emissions and increase the efficiency of our refrigeration systems to control the increasing temperature, increasing temperature of the world itself due to emissions. This is what I was talking about. This is what sir was talking about, Malvi sir was talking about too, that we need to have IoT and predictive methods in our refrigeration systems, that it can constantly check whether if the cooling if the cooling has reached a certain level, it trips up by itself, or it sends an alert that we can regulate via a remote, via an app on our phone itself, so that we may have better in energy efficiency. This is also helpful for industries itself, because in industries, even even a small margin can produce a big error in the final result. So if companies are able to handle their refrigeration systems in a much more efficient manner, it will produce savings for them too. We can use for renewable purposes, we can use solar power, geothermal, or grid, or multiple sources of energy we can use for renewable because these are renewable resources which are much better to be used and are freely available for us by just setting up there's some initial cost, but then these have a long-term advantage for us. As I said, we need to design refrigeration systems for durability, repairability, end of life recovery, and that is we need to make systems using materials and designs that are repairable for an average person. If not an average person, a minor technician can do that. And we need to make them durable, that is, they can have an extended period of life, not just not just stop working after 5 to 10 years itself. We need to have some workforce development in refrigeration sector too, because there's a demand in refrigeration sector for proper technical talents that is not being fulfilled right now. But if that demand can be fulfilled, it will provide both jobs and also increase the refrigeration sector by a measurable speed. So we need to have higher training. We need to have some training initiatives too for the future generations, so that they may be able to join the sector that has a higher demand day by day. So that was my presentation. Thank you, everyone. Any questions, please?
थैंक यू अंशुमान जी। खेतान साहब, आप कुछ पूछना चाहते हैं?
यस सर, मैं पूछना नहीं चाहता, मैं तो बोलूंगा आगे।
हाँ, बताइए सर, बिल्कुल वेलकम।
Sir, I was just searching the literature, and the latest technology in refrigeration systems is that without any compressor-based system, and they say that the latest trend in the refrigeration system is thermoelectric cooling, and that is based on the famous Peltier effect. Peltier effect means that in an electric current that transforms heat from one side of the semiconductor to the other side. automatically if the DC current flows, the heat is transferred from one junction to the other junction. And HVAC, that is the new branch, it is heating, ventilation and air conditioning. So thermal control and air quality, that is the biggest challenge in the buildings, in the offices, and the moving objects in the space like satellites and all that. So there also, if we want the refrigeration and air conditioning, we cannot have a moving compressor at all. So based on that, the thermoelectric cooling is sought, and I think the latest development in the coming years, we will see in this line only, that we may see a refrigerator in the home without a compressor and an air conditioner in our room without a compressor. Thank you, sir. That was my observation.
Okay, thank you. Thank you, sir. अब मधु सर.
Yes, sir. Yes, sir. So now I think the webinar part is over, I think, isn't it? All the three presentations are over, no?
Yes, all three presentations are over.
Yes. Then I will make some observations.
Okay.
So good afternoon to all the esteemed participants in the webinar. So at the very outset, let me congratulate IEI Gwalior Local Center for organizing a webinar under the aegis of Chemical Engineering Division on a topic very relevant to the not only to the chemical industry, other types of industries, and even for domestic purposes. So as far as chemical industry is concerned, refrigeration systems are very crucial. And as explained earlier, the principle of refrigeration is based on second law of thermodynamics, and it evolved in the 19th century. The so-called mechanical refrigeration originated in the 19th century, and it has evolved over the years. And as discussed by the first speaker and also mentioned by Vinay Kumar Shuklaji, vapor compression refrigeration is the most widely used type of refrigeration in industry now. Anyway, as our Ketan sir mentioned, our RK Ketan sir mentioned, maybe refrigerations without compressors, it may become a reality in near future. But at present, we don't have such systems which are very widely used. Now, coming to chemical industry, refrigeration systems are very crucial for controlling exothermic reactions, because many reactions release heat, and to take care of the release heat, we have to depend on refrigeration systems. Then for ensuring product quality, then for enhancing safety, and it also enables critical separation processes like distillation. Now, there are many key areas where refrigeration systems are employed in chemical process industry. One area is reaction control and safety. As I mentioned already, it manages heat from exothermic reactions and prevent, and these systems, refrigeration systems, prevent rise in temperatures. It prevents dangerous temperature spikes, and also ensures safe processing of hazardous, unstable, or flammable chemicals. In this context, I wish to point out that the Bhopal disaster, the worst industrial disaster we ever had, it was caused by the major reason for Bhopal disaster was the non-functioning of a refrigeration system provided in the methyl isocyanate storage tanks. 3 MIC storage tanks were there. But unfortunately, on that fateful day, the refrigeration system was under maintenance. And this MIC, it undergoes an exothermic polymerization reaction if some catalyst, like even a few drops of water or even like iron oxide come into contact with the methyl isocyanate, it undergoes an exothermic polymerization reaction, releasing large quantity of heat. To take care of such a situation, as a safety precaution, a refrigeration system was provided in the plant, but the management, they didn't ensure that, they could not ensure that that system was operating without failure, that the compressor was under maintenance, unfortunately. So naturally, all the vapors, the exothermic reaction took place, the vapors accumulated in the tank, and through the relief valve, all the vapors came out. So this vapor ultimately caused the Bhopal disaster. So refrigeration systems have a lot of importance in for storage systems like MIC. Even for ammonia storage tank, we have refrigeration systems. So if they fail, it can lead to catastrophic consequences. Then another important area is product quality and stability. These low temperature refrigeration systems can maintain specific low temperatures to ensure that chemical reactions proceed correctly, preserving the integrity and desired properties of final products like pharmaceuticals, polymers, and specialty chemicals. Then also it enables it improves process efficiency and yield. It can, it will improve the efficiency of operations like crystallization, distillation, and also condensation by removing heat, leading to higher yield and reduced energy consumption. Then material handling and storage. Refrigeration plays a major role. It allows for safe storage and transport of temperature sensitive raw materials and finished goods. And also there are some reactions which take place at ultra low temperatures. So for such reactions to take place, we have to provide a low temperature environment. For example, some reactions, it may go to minus 100 degree Celsius and all that. For example, reactions involving organometallic compounds, they take place at very low temperatures. So there also refrigeration plays a major role. So in essence, this refrigeration provides the precise thermal management. They provide precise thermal management necessary for safe, efficient, and high quality chemical manufacturing, making it indispensable from start to finish. That's the importance of refrigeration systems in chemical process industry. Let me compliment Gwalior local center of IEI for organizing this very important webinar. And also I should thank all the participants and all the moderator, Shuklaji, and all the speakers for making excellent presentations today. Thank you very much.
Okay, thank you, Madhu ji. मैं थोड़ा सा क्वेश्चन लेना चाहता हूँ. तो एक क्वेश्चन पूछा है, ब्रीफली एक्सप्लेन हाउ कार्बन फुटप्रिंट्स आर अफेक्टिंग आवर प्लैनेट मीन्स टू रिड्यूस. तो हबीब जी, पहले तो आपको ये पता ही होगा कि वेपर, CO2, मीथेन, नाइट्रस ऑक्साइड, ओजोन गैसेस, ये सब वायुमंडल में गर्मी को पैदा करने से रोकती हैं. ठीक है. और जो ग्रीन हाउस गैसेस हैं ग्रीन हाउस गैसेस में आपका हो गया ये जो गैसें अभी हमने बताई, इन गैसों से ओजोन लेयर पे इफेक्ट पड़ता है। ओजोन लेयर क्या काम करती है? बेसिकली हमारी सूर्य की किरणों को तो धरती तक पहुंचाती है, लेकिन उसका जो टेम्परेचर है उस टेम्परेचर को रोकने का प्रयास करता है। वो मैक्सिमम टेम्परेचर वायुमंडल में रह जाता है और प्रकाश नीचे आ जाता है। तो ये था मेन। और इसको आपने पूछा है कि रिड्यूस कैसे कर सकते हैं, तो बात यहीं पे आ जाती है कि सबसे पहले तो अभी बताया गया कि कैसे हम नेचुरल जो रेफ्रिजरेंट्स हैं उनको यूज करके और कितना मिनिमम यूज करके। अभी तक फ्रिज के बारे में ज़्यादा बात हुई, बात एसी के बारे में नहीं ज़्यादा बात हुई, जबकि आज जो का दौर जो है वो एसी को बहुत ज़्यादा प्रेफर कर रहा है हर जगह। और उस एसी से सबसे ज़्यादा कार्बन फुटप्रिंट्स निकलते हैं, और उसको रोकने का, उसको कम करने का, इसका प्रयास हम सब अगर करें, कम एसी का यूज करें, नेचुरल जो जैसे अभी आजकल ऐसे घर भी बनने लगे हैं जिनमें मतलब बाहर से तो सीमेंट और ये सब रहता है, लेकिन उसके बाद उसको एक गोबर और मिट्टी के उससे वापस से, जैसे पुराने घरों में होता था, कच्चे घरों में उसको हम जो लीपा करते थे, तो वो उसकी जब हम कोटिंग करते हैं तो उससे वो टेम्परेचर उतना नहीं बढ़ता जितना कि एक्चुअल हमको लगता है। और दूसरा जो है हमारा पर्यावरण इससे अफेक्ट हो रहा है कि जो है हम ज़्यादा, हमारा तेजी से औद्योगिक विकास हो रहा है, प्लांट कट रहे हैं, जिस रेशियो में प्लांट कट रहे हैं उस रेशियो में प्लांट लगाए नहीं जा रहे। तो इसको भी हमको ही करना है, ये कोई बाहर से अलग से कोई अलग दुनिया से लोग नहीं आएंगे इस काम को करने के लिए। तो ये सब जगह अगर हम, एक्चुअली गवर्नमेंट क्या करती है, गवर्नमेंट नॉर्म्स तो बना देती है, लेकिन उन नॉर्म्स को हम कितना फॉलो कर पाते हैं ये देखने वाली बात है। तो रिड्यूस करने का वही है कि जीएचजी गैस जो हैं वो कम उनका उत्सर्जन हो, और हम थोड़ा सा लिमिटेशन, प्रगति के लिमिटेशन को समझें। तो थैंक यू हबीब जी। अगले हमारे क्वेश्चन पूछा है एनविनो किसी बिना नाम के अटेंडी ने, उसने अपना नाम नहीं लिखा है और लिखा है कि विच गैस इज टू बी यूज्ड इन रेफ्रिजरेंट फॉर नेचर फ्रेंडली इनिशिएटिव। तो सर जो भी है आपको अपना नाम लिखना चाहिए, अगर कोई बात नहीं, अगर आप नहीं बताना चाहते अपना नाम तो अच्छी बात है। तो नेचुरल रेफ्रिजरेंट्स में आपका अमोनिया हो गया, CO2 हो गई, हाइड्रोकार्बन्स हो गए, ये सब चीज़ें लोधा जी ने अपनी पहली ही प्रेजेंटेशन में पूरा इसको डिटेल में डिस्क्राइब किया था। तो कोई बात नहीं, आपने अगर मिस कर दिया है तो उसको मैं एक्नॉलेज करता हूँ। तो ये थे हमारे 2 क्वेश्चंस जो आए थे। और छवि मैडम आपको।
विनय जी,
हाँ जी,
ये इको फ्रेंडली में बताता हूँ मैं।
हाँ हाँ,
ये अभी एक कुछ वर्षों पहले थर्मेक्स एक कंपनी है, उसने एक वेपर एब्जॉर्प्शन मशीन निकाली है।
थर्मेक्स ने।
हाँ, तो
ओके,
हमारी ये वेपर एब्जॉर्प्शन सिस्टम पे काम करती है। जैसे वेपर साइकिल, कंप्रेशन साइकिल है, इस तरह से एक साइकिल और भी है, वेपर एब्जॉर्प्शन साइकिल। इसमें ये विदाउट कंप्रेशर होता है, इसमें सिर्फ एक छोटा पंप लगाना होता है हमें। इसमें एक लिथियम ब्रोमाइड है
अच्छा,
केमिकल, उसका यूज करते हैं उसमें। और एक मतलब एक साइकिल, इसमें भी एक साइकिल बनता है। और ये बड़ी बड़ी होटल्स में भी लगाया जा सकता है, और ये इंडस्ट्री में भी लगाए जा रहे हैं। अपने एनएफएल में हमने यहाँ विजयपुर में ये 2 मशीन लगाई हैं, और अभी 3 का एक्सपेंशन और हो गया हमारा। मतलब इस तरह से 5 मशीनें यहाँ पर हो गई है। इसमें मतलब इस तरह का कोई भी मतलब रेफ्रिजरेंट हजार टाइप का, हजार्स जो होते हैं वो यूज नहीं किया, लिथियम ब्रोमाइड यूज किया है। और
अच्छा।
इसमें
तो
बस ये है
ये
कि
मतलब
थोड़ी सी एनर्जी,
लेटेस्ट हो गया।
हाँ, इसमें थोड़ी एनर्जी ज्यादा लगती है, इसलिए इंडस्ट्री पहले इसको यूज नहीं कर रही थी। और ये इसमें ये जैसे अपना यहाँ कूलिंग का सिस्टम है, इसको रिवर्स करके लगा देते हैं। तो हम ये हीट पंप का भी काम करता है। जहाँ ठंडे इलाके हैं वहां पे होटलों में हीट पंप लगाए जाते हैं, तो उसमें भी ये उपयोग होता है।
लोधा जी एक बात बताइए, ये सेफ्टी का कोई इशू है क्या इसके साथ?
नहीं, कोई नहीं है इसो, ये बहुत सेफ है। अपना यहाँ पे जो एयर कंप्रेसर में हम लोगों ने एयर को ठंडी करने के लिए, जिससे कि हमें सक्शन में टेम्परेचर कम मिले, वहां पे हमने इसको लगाया है, जिससे कि हमारा फ्लो बढ़ गया। इसमें कुछ मेंटेनेंस भी बहुत ज्यादा नहीं है। सिर्फ हमारा वैक्यूम का मेंटेन करना पड़ता है इसमें, क्योंकि एवोपरेशन इसका जो होता है वैक्यूम में जाके होता है। तो हमें उस पूरे सिस्टम के अंदर में वैक्यूम मेंटेन करना पड़ता है।
अच्छा, ये तो बहुत अच्छी बात है। तो अभी इससे कुछ सीओपी पे असर पड़ा?
नहीं, इस उससे सीओपी तो वही रहे, इसमें कम रहती थोड़ी सी, एंड इसमें वेपर कंप्रेशन साइकिल कंपेरेटिवली, लेकिन इको फ्रेंडली है ये हमारा।
अच्छा, इको फ्रेंडली है, बट सीओपी का थोड़ा सा इशू है।
हाँ, ये ना एनर्जी थोड़ी सी ज्यादा लगती है।
ओके
लेकिन
ओके।
ये छोटे साइज में भी आते हैं, बड़े साइज में भी आते हैं। तो होटल व्यवसाय वाले ये बहुत अच्छी तरह से उपयोग कर सकते हैं। बड़े
ओ-
बड़े मतलब ऑफिस है, वहां पर भी इसको लगाया जा सकता है।
ओके ओके। और किसी को कोई क्वेश्चन, कोई क्वेरी किसी की? धन्यवाद लोधा जी, आपने बहुत अच्छी जानकारी दी। अब मैं छवि मैडम से अनुरोध करूंगा कि वो धन्यवाद प्रस्ताव पारित करें।
Good evening, everyone. Yeah, I extend my heartfelt gratitude to each and everyone who attended this valuable webinar, and heartily thankful to Professor Dr. G. Madhuji, Chairman CHDB, who has guide us for such a valuable topic. I also thank to Balveer Singh Lodhi ji, Anshuman Khetan ji, and even our chairman C.S. Malvi ji, Professor Head MITS, who said that today the refrigeration is just working like an almirah. We can put each and everything. We can purchase the many things online. सर आपने बिल्कुल सही बोला। एज ए फीमेल हम लोग यही करते हैं जैसा मैम करती हैं। And I think refrigeration trends are sustainable, smart technologies, and we are using on the daily uses. And many popular trends are also doing there, as discussed by all the valuable speakers, like IoT and smart refrigeration is there, blockchain for transparency, and advanced insulation materials are also using there. Thank you so much for your valuable time for all, even to Ketan sir also who has attended this. Thank you so much. Vinay sir, thank you so much for
ओके
attending
ओके,
and
थैंक यू।
organizing such a valuable tour.
थैंक यू थैंक
And thank you again, Professor Dr. G. Madhu, for guiding us and attending this webinar. Thank you so much, sir. Thank you.
ओके, थैंक यू।
Well, I think we are at the end of this webinar. I would like to thank each one of you, all, especially the panelists, all the speakers who has enlightened us with their knowledge, and to the moderator, Sir Vinay Shukla sir, who has
Excuse
taken
me, we
the
can't hear.
question answers, taken this program thoroughly in a proper way. I would like to thank to the immediate past chairman also, and also to the honorary secretary madam. And lastly, I would like to thank the chairman of Chemical Engineering Division Board, Professor Madhu, who has enlightened us with his knowledge. He has covered, I think, almost refrigeration, refrigerant, and almost the procedure and almost everything in a very short time. I think this webinar is very fruitful to all of us. I also thank to all the listeners who have been listening to this webinar patiently for last 1.5 hours. Thank you all. With this, I will end the webinar.
Thank you. Thank you.
थैंक यू।
Thank you.